Okay, so this is example number 3, and in this particular example, we have the integral from 0 to 2 of x, and then in parentheses, we have x squared plus 1 to the 4th power. You cannot distribute that x because this expression is being raised to the 4th power, and I guess if you wanted to distribute this 4 times, which is going to be a really long process, you could, and then multiply everything by x, and then just use the shortcut for the antiderivative, but that's clearly not a very wise plan. It's going to take a really long time. So you have clearly a composite here, and we're going to go ahead and use u substitution. Again, how do you know what to let u equal is generally the function in the most complicated position. I have x, which is all by itself out here, and then have x squared plus 1, which is being raised to the 4th power. Not only that, if I take the derivative of x squared plus 1, I get 2x. And although there's not a 2, I do have an x out here. So there's two kind of, I guess, hints that my u is going to have to be x squared plus 1. Now, if I take the differential of both sides, the derivative of u is 1, and then the different times du, okay? And the derivative of x squared plus 1 is 2x, but we're doing a differential, so that's times dx. Okay, now if we start to look at this integral here and do our substitution, let me set that up. I have the integral. I still have x. What I'm going to do is I'm going to turn these around. Let me put this x to the squared plus 1 to the 4th first. And I can do this because it's multiplication, so the order is not important. Times dx. So this whole expression here is going to get replaced with u. Use a different color. So I'm going to have the integral of x squared plus 1 is just u to the 4th power. And so now I got to get rid of x dx. But I don't have x dx, I have 2x dx. So that's an easy problem to solve. We're just going to divide both sides by 2. And I'm going to get 1/2 du equal to x times dx. And I now have x dx exactly as it appears in my expression. So that means x dx is going to get replaced by 1/2 du. And the reason we're doing this is because we want to make sure we have all variables the same. So once this becomes u, the x dx has to become something in terms of u as well. So I'm going to put the 1/2 du here. Okay, now the next step that I generally do is to take out my coefficient 1/2. That usually makes things a little nicer. And then address my boundary. So I'll have u to the 4th du. And my boundary used to be 0 for x, but I need to plug that into u so that I can figure out what my new boundary is for u. So I have 0 squared plus 1. That's 1. So my new boundary will be 1. Then I'll put in the 2. So that gives me 2 squared plus 1. So that's going to be 5. Okay. So now it's time to go ahead and apply the fundamental theorem of calculus part 2 to do the integral. And you notice u to the 4th is going to be a lot easier to work with than what we started with. And that's the whole point of u substitution. You are replacing something with u to get an expression that's easier to do the antiderivative. If you get something harder, then you did the substitution wrong. So we're going to go ahead and put the 1/2 here, my little placeholder for my boundaries. This I can do the little shortcut. I'm going to add 1. So that results in u to the 5th power. And then I'm going to multiply that by 1/5, the reciprocal of the resulting power. And then it's time to plug in my boundaries. So I have 1/2. And I'm going to put 1/5. Actually, you know what's probably easier? If I go ahead and take that 1/5, which I can, and just put it outside. And it's just going to clean things up a lot nicer. Let me erase this too. So if I bring the 1/5 out, which I totally can do, that's going to become 1/10. You don't have to do that. It's just, it cleans things up a little bit better for me. And now I'm going to go ahead and put my boundary in here. So it's going to be 5 to the 5th power minus, and I'll put the bottom boundary in there, 1 to the 5th power. And then I have to remember at the end I have to multiply by 1/10. So 5 to the 5th power is a really big number. It's 3,125. And then 1 to the 5th power is just 1. So the result here is going to be 3,124 divided by 10. You do not have to divide it out, but if you reduce it, I went ahead and found that it is 1,562 over 5. And so both of these answers would work. So that's pretty much it. Example number 3 done. I'm going to do one more example and then I'm going to let you guys try it out.